If your brain is constantly taking in information, why does it forget almost all of it? You can remember a conversation from years ago, word for word, but forget someone's name 5 seconds after hearing it. Why? What's really going on in the brain when it decides this memory matters and that one not so much? If your brain lays down memory traces the moment something happens, why do most of them vanish? Well, it starts at the synaptic level, tiny connections between neurons. When something catches your attention, your brain strengthens certain synapses in a process called synaptic consolidation. But not everything gets saved. Only some synapses are tagged for long-term storage, and even then, they need backup from special proteins to lock in that memory. Your brain only produces these memory-saving proteins in limited bursts, and only when enough synapses are tagged. This bottleneck decides what gets stored and what doesn't. And guess what boosts your chances? Dopamine. If you are alert, excited, or emotionally engaged, your brain is more likely to commit that moment to long-term memory. That's why moments of surprise, passion, or stress tend to burn in deep. If the hippocampus is the memory center, why do some memories still degrade over time? Well, because memory doesn't stay in the hippocampus forever. There's a second step called systems consolidation. Over time, your hippocampus trains the neocortex to store that memory in a more permanent, distributed way. This process involves neural replays. While you rest or sleep, your hippocampus reactivates the memory over and over, embedding it deeper into the neocortex. But it's slow and selective. Familiar, related information gets absorbed faster. New or weird stuff takes more time and may not make the cut at all. That's why recent memories are more fragile than old ones. If something disrupts your hippocampus, say disease, it's the new stuff that disappears first. Older, fully consolidated memories, they've moved out and settled in. If memories are in there, why do we draw blanks at critical moments? Because memories compete. Every time you try to remember something, like where you parked your car, your brain has to sift through a pile of similar experiences. This is interference. Older memories block newer ones, proactive interference, or newer ones overwrite older ones. Retroactive interference. Think of it like files with similar names in a cluttered desktop folder. Your brain doesn't delete the old ones, it just buries them under newer, more frequently accessed data. That's why I remember your first kiss, but not what you had for lunch last Thursday. One has emotional weight and unique context, the other blends into 100 nearly identical days. This competition isn't passive. Your brain actively picks winners, usually memories that are recent, emotional, or repeated often. Everything else, it loses strength and fades away. If time erodes memory, why do some moments stay vivid for a lifetime? Traditional decay theory says that memories fade just because time passes, but that's only part of the story. Memories decay faster in the short term unless they are rehearsed or emotionally tagged. Long-term memories doesn't just dissolve, they're constantly being reshaped by experience, context, and retrieval. Research suggests that memories aren't static, they are dynamic. Each time you recall something, you're not just reviewing it, you are rewriting it. So some memories stay strong because you keep revisiting them. They get looped in your head, keeping them alive. Time matters, but without emotion, repetition, or relevance, it's just a countdown to forgetting. If forgetting seems like a flaw in the system, what if it's actually the system working right? Neuroscience shows that forgetting isn't just passive, it's active. Your brain doesn't just lose memories, it deletes them. This is called active forgetting, and it's a crucial part of mental health and flexibility. Your brain has specific mechanisms to weaken or erase certain memory traces, targeting the very cells and synapses where that data is stored. It's a controlled biochemical process involving dopamine, nitric oxide, and other pathways. But why? Well, to keep you adaptable. If your brain held on to every irrelevant detail, you'd be overwhelmed. Active forgetting helps you focus, make decisions, and move on. When this process breaks down, people may experience intrusive memories or obsessive thoughts, as seen in PTSD or anxiety disorders. If emotion boosts memory, why do some intense experiences still slip away? Well, because the amygdala, your brain's emotion processor, only flags certain moments. Not all emotions are treated equally. High arousal feelings like fear or euphoria send signals to the hippocampus to strengthen storage. But if the context doesn't matter to survival or relevance, even intense emotions might not leave a lasting trace. The amygdala does more than boost storage. It adds context. That's why you don't just remember the day you crashed your bike. You remember the smell of the road, the sound of the brakes, the jolt in your chest. Emotion doesn't just save the facts, it locks in the whole experience. But too much emotion, like in trauma, can also warp memory. Some details get burned in, others vanish. The emotional load can distort the way memories are encoded or recalled, making them feel either too sharp or oddly fragmented. If we all have hippocampus, amygdala, and neocortex, why does memory vary so widely from person to person? Well, because individual differences matter. Your memory isn't just built by biology. It's shaped by your past, your genetics, your emotional tendencies, and your environment. If you have strong prior knowledge in a topic, you're more likely to remember new related information. If something fits into your mental model of the world, your brain saves it more easily. Dopamine levels, sleep patterns, and even genetic variations in memory-related proteins affect consolidation. Age, stress, and context also change what gets remembered and how. What sticks for one person may slide off another's mind entirely. Even how often you retrieve a memory changes its shape. Recall isn't like opening a file, it's like editing it. Every time you remember something, you slightly reshape it. Your brain updates the past based on your present. So if your brain could remember everything, would your life really be better? Probably not. Your brain is a ruthless editor, for good reason. It highlights what matters, deletes what doesn't, and updates what you thought you knew. From synaptic tagging to emotional tagging, from interference to active forgetting, memory is a moving target, not a static archive. So the next time you forget something, don't beat yourself up. It might just be your brain doing its job, making room for what really counts.